Limits and derivatives, exercise 13.2. So in this exercise we completed 8 questions. Now we will find the derivative of the 9th question. So in question number 9, the first one, 2x minus 3 by 4. So we have to find derivative of this function. A function is given to us, we have to find the derivative, which is also represented as f dash of x. So this is f of x, we have to find derivative of f of x, which is nothing but f dash of x. Yes. Now let us label the function. Let f of x is equal to 2x minus 3 by 4. So we have to find derivative, so we will differentiate both sides with respect to x. We have d by dx of f of x is equal to d by dx of 2x minus 3 by 4. Now this implies, so d by dx of f of x is nothing but f dash of x. So we will write f dash of x is equal to d by dx of function minus function, difference of two functions. So from the algebra of derivatives, we have studied where we learn how to differentiate sum, difference, product, quotient and scalar times function. So from this algebra of derivatives we will solve, which I have written here, that is d by dx of u minus v is du by dx minus dv by dx. So we will apply this, that is d by dx of 2x minus d by dx of 3 by 4. Now this implies f dash of x is equal to d by dx of constant into function. So d by dx of constant into function is equal to constant times derivative of the function. Constant times derivative of the function minus derivative of the constant is 0. Derivative of the constant is 0. So this implies f dash of x is equal to 2 times derivative of x is 1. So how derivative of x is 1? D by dx of x power n is n times x power n minus 1. So d by dx of x will be, here you will have 1. So 1 into x power 1 minus 1, 1 into x power 0, 1 times 1. So therefore the final solution f dash of x is 2. Now one thing you can remember here, d by dx of 2x. d by dx of 2x is 2. d by dx of 2x. So you can remember here, d by dx of ax is a. So d by dx of 2x is 2. d by dx of 0.5x is 0.5. So you can remember this. Let's solve second sub question of 9th one. The function here is f5x cube plus 3x minus 1 into x minus 1. This is a function they have given. We have to differentiate and find f dash of x, which is also represented as d by dx of f of x. So first let us label the function. Let f of x is equal to 5x cube plus 3x minus 1 into x minus 1. So this is f of x function. We will differentiate and get f dash of x or d by dx of f of x. So to get the derivative we have to differentiate, which is a verb. So differentiate both sides with respect to x, we have d by dx of f of x is equal to d by dx of 5x cube plus 3x minus 1 into x minus 1. Right. Now, how do we differentiate this? This function is in the form of function into a function, function into function, product of two function. So we have studied the algebra of derivatives, right? So here we have the formulas how to differentiate when you have sum, difference, product, quotient and scalar multiplication. So we will apply the algebra of derivatives to differentiate this. So from the algebra of derivatives, we will apply UV rule. So product of two functions. This is U and V. This implies, so d by dx of f of x is nothing but f dash of x, both are same, is equal to, so U f 5x cube plus 3x minus 1 into d by dx of x minus 1 plus x minus 1 into d by dx of 5x cube plus 3x minus 1. Now this implies f dash of x is equal to 5x cube plus 3x minus 1. Now again from the algebra of derivatives, so we will apply d by dx of u minus v. That is d by dx of x minus d by dx of 1. Always remember to put brackets plus x minus 1. Now d by dx of 5x cube plus 3x minus 1. So again from the algebra of derivatives, so when you have sum of two functions, how do you write? D by dx of u plus v, du by dx plus dv by dx. It also applies for more than two functions. So let us apply here d by dx of 5x cube plus d by dx of 3x minus d by dx of 1. Now this implies f dash of x is equal to 5x cube plus 3x minus 1. Derivative of x is 1 minus derivative of 1, derivative of constant is 0, right? So derivative of constant is 0, 1 is a constant, so we will write 0 plus x minus 1. Now derivative of 5x cube. So how do you differentiate 5x cube here? D by dx of 5x cube. So when you have a constant into function, first let us write constant outside and we will differentiate the function. Now 5 times d by dx of x cube, we will apply x power n form, right? X cube, x power n. So we will get 3 times x to the power of 3 minus 1, which is 15 times x square. So we'll write here 15x square plus d by dx of 3x. So whenever you have d by dx of ax form, you can just write a. A can be any value here. So d by dx of 3x will be 3 minus d by dx of constant is 0. Now this implies f dash of x is equal to 5x cube plus 3x minus 1. So here we got d by dx of x is 1. So I'll explain here once again. D by dx of x power 1, right? So x power 1, we will apply x power n rule, right? X power n. So in the place of n we have 1. So here we will write 1 into x to the power 1 minus 1, 1 into x power 0, which is 1. Okay. So that's how we got 1 here. Now 1 minus 0 is 1 plus x minus 1 into 15x square plus 3. Now let us multiply the terms. F dash of x is equal to, so a value into 1 will be the same value plus x minus times into this. Let us first multiply x throughout, then minus 1 throughout. So here you will get 15x cube plus 3x minus 15x square minus 3. So let us use all the like terms and simplify. So f dash of x will be 15x cube plus 5x cube will be 20x cube, and there's only one x square term, so minus 15x square. We have plus 3x which is plus 6x, and minus 1 minus 3 will be minus 4. So this is the required derivative of the function. So this is what our f dash of x or d by dx of f of x of this function. So we have applied u-v rule to simplify. You can also do it in another way. You can multiply each and every term. Okay, you can multiply each and every term, and then you can apply algebra of derivatives and also get the f dash of x. But it will be the same solution. So we completed the second one.